The next few changes we're going to be looking at are how pressures affect a reaction. We talked about before that pressures only affect gases. We're going to look at the impact today of how pressures and volumes are related to one another. So in example number 5 here, our stress, the thing we're doing to mess up our equilibrium, is to increase the pressure on our gases. But we have to think about how you increase the pressure of a gas. What I'd like you to do is kind of picture in your head a partially deflated helium balloon. It's kind of floppy. And the pressure inside a balloon, what you're feeling when you give that balloon a squeeze, you're feeling the air molecules bumping into your hands. That's what pressure is, that sensation when you squeeze a balloon. Well, if we wanted the pressure to go up, to make it feel like your partially deflated balloon was fully inflated, you could take that balloon and squeeze it into a smaller space, right? Push all the helium into one part of the balloon, and then if you gave that part a squeeze, you'd feel the pressure would go up. So the way we make the pressure go up is by making the volume go down. They're opposites of one another. So what we're going to look at now is how does decreasing the volume impact my reaction? So when we look at that reaction, we're saying we're going to run this reaction in a smaller amount of space. So the reaction has to decide which way is it going to go. It has to shift either left or right without contributing to the problem of there being less space. So what you're going to do is count the number of gaseous molecules you have on either side of the reaction. On the left-hand side, we've got 4 gas molecules, 1 molecule of nitrogen, and 3 molecules of hydrogen. On the right-hand side, we've got 2 molecules of ammonia. Well, if you don't have a lot of space to work with, and you have a choice of should I make 4 gas molecules or should I make 2, we don't want to go and make 4 gas molecules that would contribute to the space problem. We wouldn't have as much room if we made 4 molecules. So the reaction is going to shift to the right to try and fix itself. It's going to go to the side where there are less gas molecules. If you don't have a lot of space, making 2 molecules is better than making 4 molecules. Well, if we're going to the right, that means we're moving away from our nitrogen and our hydrogen, so they're going to decrease. We're moving towards our ammonia, so that guy's going to increase. And because we're moving towards the heat energy, this guy would feel hotter. In number 6, the opposite is taking place. It's telling us the volume increases. So if we suddenly have all this room, all this extra space, the reaction says, oh, let's take advantage of that extra space. I'm going to go to the left this time. So kind of what's happening inside that reaction, it says there's more space. So let's take advantage of it. And it makes more molecules. So if we're shifting to the left this time, our nitrogen and hydrogen increase. Our ammonia is going to decrease, and it would feel colder. If you scroll up in your notes right now, you'll see that there's 3 examples there. It says, now you try it. Do just that. Pause the videos here to kind of take a second and see if you could figure out those 3 before you click on the next video and see what the answers are.